Hello there, I'm Saturn5, and today I'm going to be demonstrating how to design an SSTO and launch it into orbit, as well as how to create an orbital rendezvous and dock with another spacecraft. So let's get right into it. Basically, I'm using the Mark II fuselage parts just because I like the way that they look and you unlock them before the larger parts. They can also carry a decent payload, and this is simply going to be a passenger delivery type SSTO, not a satellite launching SSTO. So you would use this for, say, carrying something or someone to the space station that you design. But as you can see, I just kind of tried to make it a little more streamlined, but the engines kind of interacted a little bit. So I moved that back just because it looked better with all 16 engine nozzles. But the reason I'm using the these engines are because they can switch between liquid fuel mode and liquid fuel and oxygen mode, so they can switch between breathing air and oxidizer. So that's why it has the air intakes, and these wings can carry liquid fuel, which is the main reason that I'm using those. This just simply makes it a lot easier to get to orbit with a more conservative amount of mass and a cheaper price. Whereas the nuclear engines, if you were to use those, which I would recommend using those, it's a little more expensive. A lot more expensive actually. But these produce quite a high amount of thrust, more than needed to get this craft into orbit. If anything, I could have just used the two on the outer or inner, because they produce so much thrust. But this is a fairly simple build, and as you can see, the price is very low compared to your average rocket if you're able to use this multiple times. Fairly soon we will begin the first test flight. You can skip to 5 minutes into the video to see the official launch. So when you're making SSTOs, you want to make sure that they produce, you want to make sure to check the center of mass, center of lift, because if the center of lift is in front of the center of mass, it will cause your vehicle to rapidly spin out of control. So to fix this, you want to make sure that you empty the fuel tanks to make sure that the center of lift is still behind the center of mass, no matter what, even when you're out of fuel. So now we're just beginning the first test flight to see how well this works. I could have edited this out, but I decided not to. Now when designing a spacecraft like this, if you are docking with a space station, you are going to need to add RCS thrusters, just to make it more maneuverable in space. But yes, I just added the liquid fuel to the engines, and we are prepared for the official launch. Make sure you have that. It makes it a lot easier if you have the resource page in the top right corner of your screen, so that you know how much liquid fuel you're using in order to get an estimation of how much you're going to need to get officially all the way into orbit. And then you're just going to go in a straight line. Now, switch over to the oxidizer mode, just in order to get an orbit of approximately 100,000 meters or 100 kilometers. And that's where the docking tutorial will begin at, around 100,000 meters. So yes, there we go. We just passed the Kármán line, or in this game it's 70,000 meters. And we are officially in space. So you want to just, it's very useful to use maneuver nodes. They greatly help your orbit. Or they greatly help the accuracy of your orbit. Arrival time is halfway through the burn time. And that will ensure that you get a nearly stable orbit, almost exact to where your maneuver node is. So right here we will continue to adjust our orbit until it's stable at 100,000 meters. It's very important when you're preparing for orbital rendezvous or just orbits in general that you have a stable orbit exactly where you want it. And in this case I want it at 100,000 meters because it's a fairly simple orbit. Another thing about these engines, when they're in the air breathing mode, they can produce around 400 kilonewtons of thrust. Rather, in oxidizer mode, they can only produce around 105. So there's a big difference, and it's much preferred for me to use the air breathing mode over the oxidizer mode. But you want to make sure that you have just enough fuel to get back to the landing site, and I've made sure that I have just that amount. So I would perform one orbit before coming all the way back around and burning. Now I know exactly how much fuel I will need to complete that burn, and that's about all for this part of the tutorial. Hello there, and we're back with the second half of the tutorial, docking. So, for those who haven't mastered docking, it's not too difficult once you get the hang of it. This is just a simple spacecraft. You don't even need to use the Mark III command pod. You could use the Mark I or any size, as long as the docking port matches the one on your other craft. Now, I use the shielded docking port just because it looks a little nicer, but just for the purpose of this video, I'm using this size command pod. I don't typically use this one due to the fact that it's just too large for most of my missions, and it's a fairly simple rocket, but once we get to the launch itself, I'll walk you through how to dock in the easy way versus the difficult way. Well, now that I'm finally done contemplating which engine and sized fuel tank to use, let's actually get on with the rocket itself. I apologize that took so long. But now it's just a high Delta V rocket with pretty far range. As you can see, the Rhino engine is fairly efficient, but I prefer the Saturn V style engine just because I should probably learn the name of all these parts. I have no clue what they're really called most of the time, other than the command pods and that sort of thing. Just I call it the Saturn V engine. It's basically what it is. But make sure when you're building rockets like this, you add RCS thrusters, just because, once again, it makes it a lot easier to dock due to the fact that you can maneuver more accurately in space. If you did not add RCS thrusters, you would have to just burn you'd have to burn retrograde to your target to slow down and then turn all the way back around and burn towards it once again. But you'll see very soon that how helpful RCS thrusters truly are. Now, I just picked a random crew, but when you're on true missions, it's a lot easier, or not easier. It makes more sense to have a specific crew for the missions. But we are launching the rocket now, and you'll see that I wasn't really satisfied for the amount of thrust that it generated, which it could have worked. It just would have been a slow process that I wasn't willing to record. So I went back and added boosters. That's the only thing I changed. Once again, check your stage. I added boosters firing before my engine instead of right before my engine. So I guess it wouldn't be too catastrophic. Now, if you noticed, I forgot to add parachutes, or intentionally forgot to add parachutes, for the purpose of, let's just say that this mission was originally going to the moon to perform a flyby, but Bob realizes that they forgot the parachutes. There just so happens to be a craft in space with docking capability at the moment, so they decided to rendezvous with this craft. Now, to rendezvous, it's easiest if the craft is just behind your launch site. It makes it much simpler. You have to perform less orbits. But the way a rendezvous works is if your target is ahead of you and you want to catch up to it, have your orbit below the target itself. If the target is behind you, you want your orbit to be above your target. Even though you have to accelerate more to reach that orbit, you're actually traveling at a slower velocity. Or you're not traveling at a slower velocity, but you have to cover more distance than the orbit below you. So my craft, my space plane, is at 100,000 meters. If I set my other vehicle at 101,000 meters, the docking craft will have to travel farther than the space plane, therefore making it go, quote unquote, slower. But as you, in Kerbal Space Program, there are those two little pink lines, or arrows, and the orange arrows. Your orange arrows are your primary closest to target distance. So the cheap way to, or not the cheap way, but the easy way to rendezvous with a craft is to go into target mode and burn retrograde to your target. Then once you've done that, and you're at a low velocity in comparison to your target, you aim your craft towards the target and burn until you can get those maneuver nodes, or until you can get those rendezvous nodes as close as possible. And then once you get near your rendezvous nodes, you burn retrograde to the target velocity once again. Or actually you burn retrograde to your velocity when in the target selection menu. So as you can see, I'm getting very close to this node right here. But to make it even closer, I decided to make my secondary node the closest one. So when I reach my second orbit, or once I pass my first node and I reach the second one, then I'll be closer to my craft, to the other craft, than the first one. But I decided that would work best. And then I changed my mind once again, and the intersect one could be the most efficient. Or easiest, actually. But the closer you are to your target, the better. 1 kilometer is alright, but it kind of is, it requires more work to get close, and that requires more fuel, which this rocket does not lack one bit. This probably could have made it to Mimis and back. But now we actually begin to reach our target. It's a fairly simple procedure. Just to get this stage out of the way, since the entire rocket will be docked with a target, I end up separating the bottom stage despite how much fuel is left in the tank. Now, in this video I do not actually land the SSTO, but it's just like landing a plane, which is probably one of the simplest things. But here's where the RCS thrusters come in handy. So once you burn and get close to your target, you're going to want to neutral out your velocity, so you're moving at the identical speed as your target, which would mean the target, where it says target on the nav ball, will read 0 meters per second, or close to 0 meters per second. Then if you angle your spacecraft to face a particular direction, you can simply avoid any difficulty of it spinning out of control. But as we approach the target even further, we come to a complete stop. Then, once we have stopped completely, or nearly completely, we will switch to the docking mode, which is in your bottom left corner, where it says stage and there's the green light. You click on the kind of radial looking symbol with the 3 lines, and you go to the linear control, and you have to turn on your RCS thrusters, figure out how to use them, just kind of do some practicing, but that's kind of what this video is for. And you might have to switch to rotational thrusters, but that's not recommended because that will change your momentum. Once you open the docking port on both crafts, it is fairly easy to dock. It's just a simple straight line. But a tip is, when you are coming in very close to the craft, to not waste monopropellant, just disable the SAS system, because when the docking port pulls your craft, it also turns it, and the SAS doesn't like that because it's trying to autocorrect your direction that you're facing, which ends up burning excess monopropellant. But for now, that's not very important. And I just transfer the crew, which is this rescue mission was successful. And just so as a little buffer to get back home, it makes it easier if I just transfer the fuel from the other craft into the SSTO. Now, if you look in the top right corner at the resource page, you'll see how much liquid fuel I have in comparison to oxidizer. That's just so that you have enough fuel to get back to the Kerbal Space Center if you undershoot or overshoot your target. Now, if anything seems different, this is because I am playing on the Xbox One edition of Kerbal Space Program, which is why the build and the launch were a bit slower than maybe on PC. But I hope you learned how to dock or enjoyed this video. Be sure to like, subscribe, and comment below. Your feedback does matter. It's one of the main ways that I will make my videos off of. But I would like to say thank you for watching. Have a great day, and, well, goodbye.